many points does it give you? It gives you 3 points. And how many unique planes go through those 3 points? One. If there's only one plane that goes through 3 distinct points. That's why this is a great question. And it's kind of annoying in a way because it gives you like overly nice numbers. It might get a little confusing. But you have 3 points in space. Think about it this way. Any 3 points in space, how many pieces of flat wood could be leaned against those 3 points? 1. There's one way, right? So what are the 2 things? What are the 2 things you need to write the equation of a plane? What are the 2 things you need to write for the equation of a plane? Nope. I need a point. Yes, excuse me. So a point, any point, and what? And a normal vector. Well, what do we already have? We have 3 points, right? So we could choose any one of them. It's kind of like when you have point slope form. If you have multiple points on one line, doesn't matter what point you choose on the line. No. So we already have this. So what are we looking for? Normal vector. So this is not meant to be a 2-scale drawing in any way, but if I were to draw 3 points in space, so let's say I had 3 points sitting in space like this. Here are our 3 points. Yay, they're sitting in space. So let's call, I don't know, there's 3 points. Doesn't really matter which one is which. The point is we need to find a vector that is normal to that plane. Everybody sees that plane floating in space? How do we know how to generate a vector that is normal to 2 vectors, right? Using the what? Cross product. So for example, if we labeled one of these, I don't know, U, and we labeled another one of them V, what do we get if we do U cross V? What do we get? A vector that is normal to both U and V. And therefore we get a vector that is perpendicular to the plane. Doesn't matter what direction we go in. No, it could go up or down. We could do V cross U or U cross V. It's still perpendicular. It doesn't matter which one. It's still going to give us an equation that is the same. So let's just call these 3 points whatever we want to call them, but in whatever order we want. 1, 0, 0, 0, 1, 0, and 0, 0, 1. So if we label them like in this convention, can someone tell me what vector U is going to be? It goes from this point A to this point B. So from A to B, what's the x component? -1, and then what? 1, and then 0. And what's V going to be? -1, 0, and 1. So we need to do U cross V. So you multiply the components and add them together. That's going to be -1 times -1 plus what? 1 times, oh, excuse me, cross product. What am I doing? I'm doing the dot product here. Excuse me. How do I go about setting up the, it was my mistake for thinking about what I did on the poll question. Excuse me. If I want to set up the cross product, what was that method I gave you for doing the cross product? Using a matrix and using the determinant. So that method I gave you was, what do you put across the top? I, J, and K, and then which one do you put next? The first one, right? What happens if I put V first? You get the opposite direction. In this case, are we okay with that? Yeah, but you need to be really careful because sometimes it's going to matter a great deal. You're not going to get what I'm asking you for. Like if I ask you, what is U cross V, and you flip them, you're going to get a different answer. Exactly. So what you do here is, it's going to be super tempting, kids. I'm just warning you right now. It's going to be super tempting to not write out a bunch of steps on this. What happens if you make one multiplication mistake, get a sign wrong? What happens to the answer? It's not like it's like off by like a percentage point. All of a sudden you get something that makes no sense whatsoever. You with me so far? So do it real carefully. So the first one's going to be 1 times 1 minus 0 times 0 times what? I minus parentheses -1 times 1 minus 0 times -1, what? J. And I always run out of space, so I always have to do this. Plus what? -1 times 0 minus -1 times 1, K. Let's take a look at this. Let's just take 1 minute to meditate on this and make sure I did it. So what do you get here? You end up with what? I? Is it plus J? I think it's plus, yeah, because this goes away, right? That one goes away right there. Negative 1 times 1 negative, so it's going to be plus j. And then what do we end up with there? We get 0 plus k. So what's that vector? 1, 1, 1. Okay, assuming that that's correct, do we now have the normal vector? Yeah. Does the normal vector have to be a unit vector when you're writing the equation of a plane? No. You just need a scalar multiple of any normal vector. It doesn't matter. We could put 6, 6, 6 in there. Well, it's a bad choice, but 5, 5, 5, whatever you want to do. But we know that the ratio is, they're all 1 to 1. So if we now have a point, which point do you want to use? Because we have to use any point we want.
1, 0, 0.
How about 1, 0, 0? Let's use this point. What was that equation? Do you remember the general equation?
A times x minus x sub 0.
Yep.
Plus b times x, y minus y.
The sub 0. Yep.
Plus c times z minus
Mm-hmm.
equals 0.
So our normal vector was 1, 1, 1, right? And what was our point?
1, 1, 0.
1, is it 1, 1, 0?
No, 1,
Was it?
0, 0.
We said 1, 0, 0, yeah, okay. I think it was 1, 0, 0. So what do we have here? X minus 1, y minus, z minus 0. So you could stop right there. That would be a totally fine equation right there. Could you simplify that a little bit? Absolutely. Yes, you could. Now why, can you tell me why I would really like at this point to see this form of the answer? Why is this really helpful for me to make sure you kind of stop at?
So that you can see all the points.
Exactly. It's really easy. This way I know, like, what point did you plug in? What normal vector did you use? The normal vector is always easy to see because it's always the coefficient of x, y, and z, but the point you plug in isn't always because you might do the algebra and move it over, then I have to deconstruct it or look. For now, that's fine. I know it feels weird, kind of like point slope form in algebra land. Like, I can't leave it as y minus y, 1 equals m times. Yes, you can, and you will. Just leave it there for now. Are there times when you must simplify? Sure, absolutely. Yes, Tina?
So like, no math. So
Using right there, that's the determinant of a 3 by 3 matrix. And each of these, what are each of these? This is the determinant of a 2 by 2 matrix. So the determinant of a 3 by 3 is just 3 2 by 2 determinants. It's important to realize that because can you do the determinant of a 4 by 4? Mm-hmm.
Yes.
The determinant of a 4 by 4 is 4 3 by 3 determinants. And how many 2 by 2 determinants do you need for a 3 by 3? 3. So it's 4 times 3 is 12. So a 4 by 4 determinant is 12 2 by 2s. Yes, Ali? Okay. So if I were to draw you a picture here, let me draw you a picture. We have 3 directions, right? What comes forward? I. What goes to the right?
J.
And what goes up?
K.
So those are 3 vectors, right?
Yes.
What is I cross j going to be equal to? If you cross I with j, what's the vector that's perpendicular to both I and j?
K.
K. What about j cross I?
Negative K.
Negative k. Exactly. Could we do that using the matrix, the determinant form that we just used? Everybody see how it works there? So if you go from I to j, you're pointing up. If you go from j to I, you're pointing down. Now, could we do this using the method we just used with the matrix? Yes, because what's the component form for I? 1, 0, 0. What's the component form for j? 0, 1, 0. Could we take these 2 matrices and do exactly what you just did? Yes. What is that going to be? You know it because you just looked at the picture. What's it going to be? 0, 0, 1. Exactly. But could you do it out? Yes, you should be able to do it out. You should. Excellent. Here are the particulars for the rules that you get for cross products. If you have 2 cross products and you flip the order, it should make sense now. If you do I cross j, it was k.
Oh.
J cross I goes down. So what happens if you switch the order? It goes the opposite direction. What is lambda? What type of thing is lambda? Any constant. Any scalar, any constant, right? So basically what this says is you get to treat a scalar just like you think you should. Where can the scalar go effectively? Anywhere you want. You can do it first to 1, or at the end, or first to the other one. Does it matter where you do it? No. What about this one? If you add 2 vectors and cross it, look what you get to do. This is kind of cool. If you're crossing the sum of 2 vectors, what could you do first theoretically? Cross them first and then what? This is actually kind of cool too because in reverse, like let's say I gave you this, u cross v plus u cross w, what could you do instead? add them together, and then cross. Why would it be maybe advantageous to do this for this instead of this?
Because it's easier to do that.
How many crosses are there? One. What's easier, adding or crossing?
Adding.
Adding is easier, right? So this way you have to add and then cross once. Over here you have to cross twice and then add. So those are just the basic properties of cross. Wanted the area of this base right here. What's the area of that base?
B cross C.
It's B cross C, right? Magnitude, right? You need the because crossing is a what? Crossing is gives you a vector, and if you cross, you get a vector that's perpendicular, but that's not what you're interested in this point. You want the area. Okay, so what we have right now is the area of this base. The formula we're going to use for the area of the entire parallelepiped, right? Area of parallelepiped is going to be the base times the height. That's what you need. You need the base and the height. Are you with me so far? Okay. So if the height is this vector. So this is kind of I need you to this picture is a little confusing because is B cross C necessarily the same height as A? No. Or is it? That's my question to you. Cosine theta is equal to what? The height over what? The magnitude of what? Do you agree with that? Are you okay with that? Okay, so what does H equal?
Magnitude of A
Times cosine of theta. Are you with me so far, everybody? Okay, so the area of this parallelepiped, and it's not area, because we're in 3 dimensions. What's it called? The volume of the parallelepiped is equal to the area of the base times the what? The area of the height. Are you with? No, just the height, not times the height. Do you understand what I'm trying to say? I'm not doing too well today, I guess. Well, do we have the area of the base? Whereas this is the area of the base, correct? And what's this right here? That is the height. So what's the volume going to be equal to? B cross C of that, the magnitude of that, times A cosine theta. Yeah, you're seeing it now. Let's look at this for 1 second here. Are you okay? Raise your hand if you're okay with that statement I just wrote right there. Does that kind of look like something we've seen before? This is what? This is the dot product of what? Be really careful. What is this the dot product of? This is equal to
of the normal B cross C and A.
Yes. Look at that, everybody. If you have, what's the dot product? Don't even look at this for a second. What's the dot product of U and V?
U times magnitude B
Times cosine theta, right? If you have two vectors, right, and you want the dot product of the two, you do magnitude of one times the magnitude of the other times what? Cosine of the internal angle, right? What is B cross C? A vector, right? It's this vector, magnitude, times the magnitude of this vector, cosine theta. So what is this? This is the dot product of two vectors. And I got to put a little hat across this. There we go. What's the B vector? 3, 2, 1, 1, 0, 3. So if we actually do this out, what is it? 1 times 2 times 3 minus 1 times 0 minus 2 times 3 times 3 minus 1 times 1 plus 3 times 0 minus 2 times 1. What do you end up with? 1 times 6 minus 2 times 8 plus, minus what? Or so plus 3 times. So what do you end up with? 6 minus 16 minus 6, which is negative 16. You do the absolute value and you end up with 16. So the shorthand way, what's really cool, is that this formula right here is actually just a 3 by 3 determinant.
Are we still crossing things out when we're doing that?
If it helps you, yes, you should. If you can do it consistently without doing it, it's fine. It's also a little, it's one of the things that's luxurious about, one of the many things that's luxurious about using a surface is I can just go like, big line, and then perfect erase. Big line, perfect erase. You can't really do that on your, but you do like a light line and then hopefully not black out your work. Okay, 5. It's kind of cool. So what I'm hoping is that the middle ground is being filled in here. It seems really random. Like, why do they call it, why do they give this thing a special name? Well, it comes up a lot. So someone figured out, oh, the area of a parallelepiped is B cross C dot A. But it turns out that B cross C dot A is equal to what? The determinant of that. Determinants come up all over the place. You use it to find inverses of matrices. You use it to do this in coding. It's really cool stuff. Really cool stuff. I like it a lot. Okay, so let's pull this out. Okay. So if I gave you there we go. A simpler question. Find the area of the parallelogram with those two edges. Do that for me right now by yourself. Find me the area of that parallelogram with those two edges. How many dimensions are you in?
Two.
No.
Three.
E, R, son, I, J, K. Who has an answer? Do you check it with somebody next to you?
I got three. Just go over the one next.
How do you do this? What do you have to do first?
Cross.
And then once you get the cross product, what do you do? Magnitude of the cross product. What did you get for the cross product? Did you do V cross? Who did V cross W? What did you get, Brenna, for the V cross W? What vector did you get?
11I minus 7J plus 5.
Who got that? Nice. So your magnitude of V cross W is going to be 11 squared plus 7 squared plus 5 squared, like this. Correct? Yay. Nice. So you've now found the magnitude of the cross product. Excellent. Very, very nice. Okay. So how about I pick a good one for you to do? How about I pick a really good one for you to do? Where's the product? Where is it? Oh, that's right. get up to the board because we have another 5 minutes or so. Everybody to the board. Start working on / show me the thought process you put towards solving this. I gave this to you last class and said you needed to prove this. We never did that. The area of a parallelogram is the 2x2 determinant using the difference of sign. I gave this to you before I asked you to think about it, so show me some work. And you're starting with this. The area of the parallelogram is magnitude of S times the magnitude of R times sine of beta minus alpha. That's what you're starting with. The area of that, the area of the parallelogram is that right there.